Hello everyone, in this video I will explain you S7 1200 PLC hardware. How the hardware of S7 1200 PLC look like, what are the components that make up S7 1200 PLC itself. How to connect your laptop in order to program S7 1200 PLC to any CPU. This video will explain you the connections of a laptop to a CPU to write your first code. You will also learn the wiring of S7 1200 PLC, how to do the wiring, how to power up different components. All the wiring would be explained in this video as well. Not only that, I will go to one of the plant and show you the real hardware panel of S7 1200 PLC in a real-time industry. I will also explain you the connections of S7 1200 PLC panel to our different instruments in the plant. Not only that, this video also covers the wiring diagram of S7 1200 PLC. Following up, we will be starting up our basics in the programming as well in this video. So if you are new and you haven't seen real hardware so far and you wanted to have a feeling of it, this video is right for you.
So this guy right here, you can see here, is a S7 1200 PLC. This is how it looks like. This is no more a kind of simulated classes. These will be real-time classes. So let's start with our first session. What are the hardware components of S7 1200? Starting with a CPU. As you can see here, S7 1200 CPU, we have CPU 1214C, and you can see the CPU itself have some digital in and digital outputs. So you can see here, these are DI digital in and DO digital out. So next, IO modules. These are digital in and out modules. You can see SM1223. The next one. This one is also SM1223. These two modules have a specific digital ins and outs. You can see here digital ins and these are two digital outs. Now the selection of this digital in and digital output module is totally dependent on how many digital in and outs you have actually in the field. So now like that, we have analog output modules and input modules. We will cover that later on. So this is how actually S7 1200 PLC looks like. And now for sure, this is something that you call it power supply. So the whole purpose of that power supply is to provide the power to all the modules down there. So now, this is all about the basic hardware architecture of S7 1200 PLC. We are going to start our wiring connection with the PLC. Starting with the power supply. The power supply is coming from here. So we are now going to have a wiring connection for a PLC. So the first connection with the power supply is with the neutral and live. Neutral will go to the neutral and live will go to live. Make sure when you are making the connection, the power supply should be cut off. Now, this is the power supply. So the power supply is from AB. One end is AC supply coming from power outlet and another end is a DC. So the whole purpose of this power supply is to convert AC signal to 24 volt DC. This 24 DC is used to power on all the input modules and output modules and CPU of PLC. So now the next phase is to have a wiring connection between 24 volt DC output of that power supply to the input modules and output modules. So we are making the connections, you can see here. So these are the connections. Okay. In next phase, here we are going to first power on our CPU. So you can see here there is a 24 volt connections here, L positive and M. You can see here L positive is a positive end of power supply and M is negative. So we will make the connection accordingly. Here we go. Positive end is going to L positive. The negative end from the power supply is going to M, which is actually negative end. Tighten the connections. So now we are going to turn on the power supply. Our CPU is now in running mode. Yes. So our CPU is running now. You can see here the indications. So you can see here all associated modules are also powered on. And that's how we are able to power on our CPU.
Now is the time to make our setup ready. This is our DIN rail. If you're wondering what is DIN rail is a metal rail that is used for mounting circuit breaker and other industrial control equipment inside the equipment rack. You're gonna see every component that is going to be installed and how these components are actually sharing the data and power with each other. We are going to install CPU first into the DIN rail. First we are gonna open this mechanical latch. Here we go. Then we're gonna close it. It will tighten up that CPU into the DIN rail. Now for the power connection. There was a question in last class how CPU is sharing the power with other I/O modules. So now I'm gonna show you. Here is the trick. So CPU is sharing its data and its power by using this port. Now we are gonna connect next I/O module in line, and you will see how these are gonna be connected. So you can see here. This port will be definitely getting into this slot, and by this way this CPU will share the data to this I/O module. Now we are going to connect it in front of you so that you can visualize it. Here we go. So now this connection is already made. And similar way, this connection will be a connection for other I/O module that will connect on to the DIN rail. So here we go, there is another I/O module that's ready. We are going to connect it in line with the first I/O module. I hope this question is very much clear to you, how CPU is sharing the data and power with other I/O modules. Now to power up all the CPUs and I/O modules, we need a power supply. So the first thing first, we are gonna power up our CPU by using this power supply. So then this CPU is already connected. I showed you how it's connected to the other I/O module to share the power and data. Now it's the time to make the cable connection. We will be doing it a bit fast so that we don't waste any time here. So we are going to close it because there is no other I/O modules in line. So we have to close this. Today we are going to talk about real PLC panel, how it looks like, what are the components inside the PLC panel. For that we have to travel to some plant and see control panel. Now I'm going to show you how the PLC panel in a real feed looks like. This is one of the S7 1200 PLC panel you can see here. If you come closer you will see that this is the first point where we have to connect our signal. Now we are going to field level, where you will understand how the signal is coming from the field level to a PLC. Starting with the instrumentation in the field, and we are at the moment in the field side where we have our transmitters. You can see here this one and this one. These are the sensing elements. You can say that these are there to measure the flow in these pipelines. So from there on you can see these wires, these are going to our PLC. And I will show you where exactly it is terminating in a PLC end. Now we have discussed the field level. It's the time to get back to PLC panel and explain further. This is the first connection point where we are connecting our signals that are coming from the field end. I have showed you the field end. This is one of the transmitter you have seen there. So like in the field, we have transmitter, pressure switches, and different other switches are there. So we are getting the signals from the field on this particular connection point, or you can say it's an interface between your PLC I/O cards and the field element. The signals you can see here are coming first on these TBs. From the output of these TBs, you can see the signals are going to the I/O cards. You can see here, these are the I/O cards. S7, this is the S7 1200 PLC CPU. You can have a look at that. And it's, as we discussed in last class, S7 1200 PLC have its own inputs, digital inputs and outputs that are within the CPU. And we have some extension module you can see here as we discussed last time, SM1223. The signals from TBs are coming there and connecting over there. So now from the network point of view, you can see this is a network switch, a Profinet switch, you can say that, where we have a cables coming from different devices. Like HMI, we have a connection to HMI from one of the cable, and we have a connection to these servo drives from another cable. And this is how it is connecting actually. You can see here, this safety relay is connected to the door interlocks and emergency stop. Apart from it, if you can see here in this panel, we have a power supply. This power supply, you are already aware, this is used to power up all the devices in the rack. Apart from it, you can see these are circuit breakers. If the power is coming from 220 volt, it have to pass through that, and then it is going to power supply or any other device that is operating on 220 volt. So this is how it looks like when you talk about the S7 1200 PLC rack. We have checked our PLC panel. Now it's the time to explain the drawing, how it looks like. Is it going to be very simple for you? I'm going to show you bit and pieces about that in our drawing, so it will be very, very interesting for you. So let's have a look at that. Let's see. These are our inputs that are coming in to our PLC. You can see here, these are all inputs. These inputs are coming from field, and this is 24 volt positive, you can see here. And from here on, you have seen already, I have explained you L, M, positive and negative, and these are coming from the power supply. Output side, if you see, this is actually output of a PLC. It is going to our final control elements, actuators, and different industrial equipments. I have shown you one switch where you have seen few Profinet cables that were connected in there. One was coming from HMI, you can see here, also the same thing. And one was coming from the servo motor. So this switch is for that purpose. Just an overview of how drawing of S7 1200 PLC look like. It would be very good if you see some real-time example in industries. That will make your concept more clear. As you are seeing our videos, we are putting a lot of effort to make these kind of videos. And we have to travel to some plant to make these kind of videos. We need a small favor from your end. Subscribe this channel. Share this amazing content with those people who are actually looking for this information so that it can help someone. If you already watched our last video about how to take a Siemens PLC backup, then you might be already aware that we are using MPI cable in the case of S7 300 PLC and 400 PLC. But which cable we will be using for connection of S7 1200 PLC and our laptop in the case of S7 1200 PLC. So the cable we will be using in the case of S7 1200 PLC is Ethernet cable.
Now, in order to program your PLC, or in order to see what is inside your PLC, all you have to do is you have to have a connection with your laptop and your PLC. For that, all you have to do is, there's an Ethernet port here. You can see here, this is the Ethernet port. So we have to make a connection right there. Other end of that cable will connect to the laptop. And for that, we are going to make a connection like this. Now our laptop and our PLC is connected. So now we are going to open up our TIA Portal software. Our software is now open up. Is the time to click on create a new project. Name it as you like, whatever name you want. We are naming it as a test 1, and then we are gonna click on create. So now next step, you have to go to the devices and add device.
just select on that. You will find all CPUs that are available in Siemens PLCs. Like if we talk about 1200, 1500, 300, 400, 200. So this TIA portal is a software that will give you an ability to program all PLCs available from Siemens. So this is very interesting thing. Not only that, you can also program HMIs, PC systems and other devices. We are not going to talk about that in today's class. In this class, we are going to program a very simple S7 1200 PLC program. So we are selecting a CPU. Any CPU you want, you can select based on your needs, whatever you have actually. But now we are going to make sure which CPU we have. So our CPU is 1214C. So we have to see whether we have 1214C here or not. So 1214C, there are two different types. So we have to make sure which one is ours. So we have selected exactly the same CPU with the same order number to make sure what we have, actual hardware, we are configuring the same in our software. We have to just go in there, project view, click on that. We have to make sure the device configuration. So just click on device configuration first. Yes, what we have now, what we have actual in the hardware, we are gonna make sure we have that already on our software hardware configuration. So for that, we have to see again our IO modules. 1BH30 is right there. So we have selected one IO module, 1BH30. You have seen that we have two IO modules, two digital in and out modules. And the first one we have already selected. And another one is, you can see here, is 2231BL300XB0. So we are going to move this and put it into the software hardware configuration. So now our system configuration, our hardware configuration for system, what we have actual is already ready for sure. If you're going to talk to this CPU or this PLC, there should be some address, right, by which it is identified. And every S7 1200 PLC, every 1200 PLC have a specific IP by which you're gonna identify it. So we're gonna define an IP address here. Make sure whatever is the real hardware address or real hardware IP of a PLC, you have to identify here. That's very important. Now your laptop is connected to that CPU. If you're not on the same network, you can't talk to that PLC. So two devices on the network can only talk to each other if they are on the same network. So we have to specify any IP that is on the same network. For that, we have to go to the Open Network and Sharing Center, open it up and go to the adapter set, LAN, local area connection, first one, properties, and then you have to go to the IP version 4, double click on that, and here is what you have to specify, any IP with the same network, 192.168.0. anything except what you have with your PLC and except what you have on your network, because we are having two devices on the network, so it's fine to select any other number than that CPU, then the PLC one. So we are gonna select 100 here. Subnet mask, it should be the default one, don't need to change anything, just select on OK. And now you are on the same network as a PLC. So now this system can talk to that PLC. So that's how we are going to configure our system. Go to the program blocks, go to the main, double click on that and add some networks. We are going to talk about very simple project in first class. We are not here to talk about anything advanced. We are going to take one single input. It's just like a fan, it's just like a light bulb. When you turn it on, it will turn on. When you turn it off, it will turn off. For example, in the case of light, if you turn it on, it will turn on. In the case of fan, if you turn it on, it will be on. and if you turn it off, it will be off. So same case here, we have to make sure till the time input is there, output will remain high. For that, we are going to take one input. In connection to that input, there is an output. So in a Siemens, there is a way to identify inputs and outputs. If we talk about I0.0, this is gonna be the first digital input. I for input 0.0 is first 0 will define the byte number, and the second one will define the bit number. So every byte have 8 bits in that. When we have 8 bits, like for example 0.0 to 0.7, and then next will be 1.0, and same way it will reach to 1.7, and then 2.0 to 2.7, and it will go on and on like this. So this is the address, but for simplicity, we are just gonna take our first input, I0.0. I0.0 is input that is coming from input module, digital IO module. So then if you have to define the tag for that, you can make sure like whatever, for example, input 1 or input, whatever the name you have to give it, so that other guy who is coming in later on and seeing your code, he should not be like in a crazy mind. So he should be very much clear what you have in your code. Now for output identification, we have outputs like Q for output, 0.0 for first, and similar up to 0.7, and then 1.0 to 1.7, and then 2.0, similar fashion. So we have identified Q0.0, our first output, and we have to define a name for that. So remember, like whatever name you have actually, so you can define. So we are just gonna give it output 1. So now our simple program is almost ready. This is a selector switch I0.0. It is connected to I0.0, and this is light indication, and is connected to the output Q0.0. Next thing, we will download that program to the CPU. So for that, what we have to do, just click on download and select here interface Profinet. So in order to simulate it, this I0.0, when we will turn it on, we have to turn on the selector. So when we turn on the selector, you can see the light is also on now. So when we turn it off, now we are going to turn it off. You can see the light will also be off. So it's similar way, you can see the similar fashion into the programming. When we are going to turn on the selector button, similar way you can see into the online view, output is also high. So that's what we have to program in today's class.
Hello and welcome to another session on IT and Automation Academy. Today we are going to discuss about new chapter.
My name is Noman and you are watching IT and Automation Academy's YouTube channel.
What we are going to talk about today, there are 3 things we are going to discuss. First of all, we will be talking about what is NO and NC contact, and then we will be talking about how we can connect NO and NC type of momentary push button to our PLC. And the third point we are going to discuss in today's class will be how to program NC and NO type of momentary push button. Now we will be talking about NO and NC type of momentary push button. NO type of momentary push button look like this, and NC type of momentary push button look like this. What is NO type of momentary push button? In NO, in normal condition, we have an open circuit. So whatever the device, whatever the final element is connected with that particular push button, for example, if it is a light, in normal condition, light would be turned off because that circuit is open in normal condition.
Normally open mean normally there is no current passing through it. So when we will press that button, after pressing that, we will have that connection complete, or you can say that circuit complete, and the associated device will be turned on. For example, in our case, it is light. So light will be on. Now in NC type of a push button, we have different scenario. In NC, it is a normally closed contact, or you can say it's a normally closed. In normally closed type of push button, what happened in normal condition, whatever the final element, for example, in our case, it's a light. So in normal condition, when we don't press the button, light will be on. But when we will press the button, that will open up that circuit. So that circuit will be open, and when we will be pressing that push button, so the associated light will be turned off. So I will repeat this scenario again. In normally closed type of momentary push button, when we haven't pressed it, it's normally closed. That means in normal condition, our circuit is complete, and the associated final element, like in our case it's light, will be turned on in normal condition. So when we will press this button, it will open up the circuit, and the associated light with that will be off, because our circuit will be open when we will press the button. So that's how normally open and normally closed contact work. Now is the time to talk about little more about that. So we have one normally open and normally closed type of push button. So we are going to make a wiring connection between NO and NC type of momentary push button with our PLC. First of all, for normally open contact, we are going to make a wiring connection. What we will do, from the PLC power supply, one wire is coming into the normally open push button, the green color you can see here. So we will make a wiring connection like this. So another end of that push button will be connected to PLC input. So what will happen in normally open condition, as we talk about that in detail, when nobody press the button, this circuit is open. So in normal condition, there will be no current passing through it. So that's why there will be no input going to the PLC, and there would be no activity at the final control element. If it is light, that will be off. When we will press it, for sure, you know that it's normally open. When we will press this push button, it will close the circuit. We will have an input at the input of a PLC. Similar fashion, we will be making a wiring connection for normally closed contact. So what we will be doing it same way. A power supply is coming in, 24 volt coming from the CPU, and the another end of that is going to be connected to input card of a PLC. So that's just a simple wiring connection. So this is NO type of momentary push button. One wire is coming from the output of this push button to our input card channel number 1 right here. And from another NC type of push button, this wire you might see is coming in from there to this particular channel number 2. You might be wondering how we are providing negative supply for these inputs, input 1 and 2 and respectively other inputs. What we have here, you might see this is L positive. So this is a positive and M is negative. And we have a jumper, you might see here. Why we are using this jumper? We are providing this common negative to all channels from there. If you see here, the marking here, you might notice that this M and this M is connected to the jumper. From here on, we have a common negative for all the channels. We are providing common negative to all channels from there on, and these are actually internally connected. For more understanding, all we have to do is we have to go for the programming, because program will clear your all doubts and you will see the real-time simulations. For that, you have to just stay connected and keep on watching. Now we are going to program our PLC project. Before starting actual program, I want to show you there on the top bar, if you can see normally open and normally closed contacts here. Remember, we have to make sure whatever we have actually in the hardware, like for example, if we have a push button from the field end, it can be also normally open and normally closed contact. You have already understanding of that particular thing, because I showed you how actually normally open and normally closed push buttons are and how it works. Now assume we have a normally open contact at the field and we are going to program a very simple project. Like when we will press a push button, light will turn on. As this is a momentary push button, when we will just remove our hand from there, it's a momentary. So momentary means that at the instant you push the button, there will be only pulse. And when you're going to remove your hand from there, the output will go off. We're going to just practice a small project here, just for understanding, so that you have an idea about that. So let's go and program a simple project. We are taking a normally open contact from there. For sure, we have to select the input here. and we are selecting I0.0 coming from the input of the PLC. Q0.0 is our output, and this I0.0 is actually coming from where? It's a push button, right? Remember we discussed about normally open momentary type of push button, so we are connected through that to our output. So, and our output is a light, which you have already seen. We will definitely show you simulation so that you will have an idea about that. So now our program is ready. We are going to just download in our PLC so that you can have a look about that. After this program, we will also program for NC contact, so that you have an idea what's going on from the field point of view and what is exactly in a programming interface. Remember, as it's a pulse just for a few milliseconds, so it will be impossible for us to see that output in a simulator. You can only see in a light, like you have a physical interface there. Like if you will visualize the light, at that point you can only see that output. You can't see it here. So we are going to download our program into the PLC. You know, if you haven't watched our last video, then it might not make any sense for you to watch this video. I highly recommend you, if you haven't watched our first and second video, go and watch first and second video and then come up here. Now we are going to just download this project into the PLC. Now just click on load. It's just gonna take some moments more, and then you can overwrite your program into the PLC. Here we go. So our program is already downloaded into the PLC. It's a time to show you the actual setup from the hardware point of view first, and then we will talk about the software. So this is I0.0, you can see here. So this is our input and this is our output. This light indication is our output, this is our input. So now we will press input and you will see that output will be on for a few milliseconds. You can see now we have a momentary push button, green light, green color momentary push button. By momentary we mean this will just give a momentary kind of an input. This will just give a pulse to the input of a PLC. For a millisecond only this input will be high, and that shows when we will press this I0.0 just for a few moments, just for that particular moment, we will have our output high. And if in the case you want to see that from the program point of view, it would be very much difficult for you to recognize that whether it was on and off, whether it was on or not. So it's very much, and it should be very much clear. If you want to visualize it, you can only visualize it by its actual hardware. Maybe it would be very difficult for you to see from the simulator or from the simulation or from the online simulation view. So now we are going to press this I0.0 green momentary push button. You can see after that how it works. So we are going to press this I0.0. You will see that output was on for a second, just for that moment. So if you will press it for example for a long time, you will see it will be on. So this is momentary. Momentary is just for that moment. So you press it, you will have an output. So now same thing you can see from the program itself. When we are pressing from the field, we are actually pressing from the field now. We are having output at that time, just for that moment. So that's how it works when we talk about normally open contact. When we have a normally open momentary type of push button in the field, and we have configured the same thing here. Now we are going to play with normally close contact. If we have a normally close contact in the field and we are using the same program, how it is going to work in that scenario. So now we are going to change our input from I0.0 to I0.1. No, remember I0.1 is coming from normally close momentary type of push button, which you have seen that is in red color in our actual hardware. So now our program is ready. So once we will have a normally close contact in the field, then how it's going to work, we are going to show you now. Just download this program similar way that you have done earlier. We will do this process a little fast so that we don't waste any time. Just going to online.
Now we are connected to this red button. Because this is normally close contact, because this is normally closed type of momentary push button, so in normal condition we will have an output here. You can see here this output is always on, and you can see from the indication here Q 0.0 is also on, and our I 0.1 is also on from the PLC point of view. So when we will press this button, you will see our output will be off and this light will turn off. We are going to press this red button now. You see that when you are pressing it, because it's normally closed, normally closed mean in normal condition this circuit is closed, and when you will press it, it will open it. When you will open it, it will disturb the flow of the current from there, and you will definitely have your output low, and your light will be off in that condition. So now we have programmed in a way that we have actual normally close contact in the field, and we are programming that one in normally open condition in our program. Now we will do this similar project in a way. We have NC here, and we have also NC into the programming side, so that would be a bit different. Let's do it. Now we are going to take normally close contact here. From the programming point of view, you know that we have on the top bar normally close contact. We are placing it into the programming, and we are just giving NC. We are going to just select here I 0.0. Sorry, we are going to select I 0.1, which is coming from the red push button, and which is actually normally close type of momentary push button. So now we are going to download that program, and we'll show you how it works. So now you can see here I 0.1, which is red button. It is momentary, so we haven't pushed it. So when we program it in a way that we have taken normally close contact there, even into the PLC, normally close contact means that whatever will be there, it will be reverted. It will be opposite of that. For example, if we have a true conditions from hardware point of view, then it would be there, it would be reverted to 0. So similar manner, you can see that we don't have any output in that condition. So when we are going to press this button, you should have an output here. I will show you. So we will press this button, you will see that. Because what happened, it is normally close contact. So when we will press this, it will make that particular input to the PLC in a low 0. So that means 0 will go to the PLC input card, and programming, because we have taken normally close contact in the programming, so that programming normally close contact will change that 0 to 1. For sure, that circuit will be closed, and we will have an output.
Let's go to the program, and we are going to program something, what we call it latch concept. Before that, I will definitely tell you what is exactly problem and why we need this latching concept. Where exactly we apply that? What is the real problem in industry which we have to sort out by using latch concept? For that, we are going to take a normally open contact here, I'm gonna give I 0.0 input that is coming from the push button NO type. We have discussed in the last class, we have the same hardware, so we're gonna use that same example. And I'm gonna take output here. You might be seeing that we are talking about same inputs and outputs. Believe me, the next thing that is coming up would be very interesting for you. Step by step, you will understand the real concept of PLC programming. So stay connected. I'm gonna download this program here. It's just gonna override because we are already connected. Now it's already downloaded, and it's the time now to simulate the real issue. What is going on? So I'm gonna take this on online view. You can see now from the input point of view, from the field point, I'm going to see something on PLC. This is our real hardware, right? So when I'm gonna press this button, you have seen that light was there just for that second. Now we are back to the real hardware. So now I'm gonna just click on this button. This is I 0.0.
when I will press this I0.0, you have seen that at that particular moment we have output. So when I release the button, at the same time our output is also not there. So this is something that we have to make sure in our program. Even if we press this button just for 1 second, this output should be still on. This is the concept I'm talking about. This is what I'm going to talk about in today's class, where we will program in such a way, even we press this button for a millisecond, just for like this, output should on until we press the stop button. So how we going to do it? Let's go back to the programming. Now I'm gonna just add another branch here. So then we will be adding in parallel. This is very important to understand. What is that actually? So we are gonna take Q0.0 here. So we are going to take this Q0.0 as a feedback. Now I will be talking this concept in detail step by step. We will be creating a problem and then solving the problem so that you understand what is going on. Now we have a scenario when we will press this I0.0 button, I0.0 push button, then our output will be on. Even for a millisecond it would be on, but because we are using this in a parallel to that input, and now in that case even our input is not there, still we will be getting this loop closed and our output would be high. I'm just going to show you. In that particular network, there is one issue. I will be showing you when we will do the simulation. So we are taking a normally open contact of our output. When our output would be high even for a millisecond, it would be acting as a feedback. So when we will press this I0.0 button, at the same time our output is high. Output normally open contact we are using as a feedback in parallel to the input. So even now this circuit is open. I know for millisecond we press this I0.0 button and after that this is open circuit, but this path is still closed and we are managing to get the output by that way. There is real issue in that particular network. I'm going to explain you step by step everything. First we will be creating the problem, I'm going to show you the problems, and then we are going to sort it out. Now let's go back to hardware simulation. So for that I have to first download this program just for a second, and now we are going to take this online. Here we go. So when I am pressing this button, our output is high. Even you see that I remove my hand from this push button, still our output is on. We have a real issue here. What is that? Now how to turn off this output? For that what we have to do? We have to have some other button. This should be start and some other stop button should be there to do so. So now let's go back to the programming and do some magics there. In the simulation you can see also when we press the button at the same time we have our output high. When our output is high, we are using a feedback of that output as a normally open contact in parallel to our input. You have seen that this circuit is open here. From the input point of view, if you see this straight line, from here on this circuit is open. But we have a parallel connection to that, which is a feedback of output that is making that circuit close, and we are getting the output. So this is very interesting thing, but we have a real issue here. How to sort it out? We have to first go back to normal programming mode, and now we have to have something here. So now we are going to use another push button, I0.1. So now this is our stop bit. Remember we have discussed about I0.1, which is coming from the normally closed contact. So I'm gonna just take a normally open contact of that into the programming, and this is going to be as a stop bit for us. This one is now acting as a start, and this is going to be stop. So what we can do here, we can play with that also. Well, I'm not going to talk about this thing. You can change it. You can change it to start, and this can be stop. Just to make your understanding very clear, this would be start and this would be stop. Now our program is ready. I'm just gonna download this project. for a second so that you can understand that. Now our project is ready. Let's go back to the online view and go back to simulator. You have seen this guy is still on, right? We have to turn it off. So I programmed this normally closed type of push button into the PLC, and that is acting as a stop button. So when I will press this button for a second even, this will open that circuit, and I will definitely show you how it works in a programming point of view. But when I'm gonna press this should close this circuit, this should turn off this light. I'm just going to do the same thing. Now you have seen that output is gone. So when I press this I0.0 again, this is latched and it is going, this light is still on, Q0.0, what we call it in the program, Q0.0 is on, and when I'm going to press this stop button, it is going to turn it off. So I hope you understand that, but now we are going to do the same thing into the programming. So when I'm pressing this button, you have seen that I0.0, when I press this button, Q0.0 is on into the program. In the simulation you can see, so because we are using output Q0.0 as a feedback to the input, so it is on. But now to close that circuit, we have another contact there which is actually coming normally close from the field. So in normal condition that would be closed. When we are going to press that, it is definitely going to open that circuit. Like I'm just going to show you. Now I'm pressing this I0.1, which is a stop button from the field. You will see that this circuit will be open, and in that condition we will have no output. That's all for today. If you like this video, hit the like button. If you haven't subscribed our YouTube channel, consider subscribing. Till next video, take care and Allah Hafiz.